Welcome to The Explainer. Today, we're digging into Go, the programming language that's, well, quietly running a huge chunk of the internet. You ever stop and wonder what makes the cloud actually work? Turns out a huge piece of that puzzle is Go. But that brings up a pretty obvious question, right? I mean, there are literally hundreds of programming languages out there, so why on earth would a company like Google go through all the trouble of making a brand new one? What was the problem they were trying to solve? Let's get into it.
The story of Go really starts with a problem that came from progress. As our computers and all the cloud infrastructure got ridiculously powerful, the tools we were using to write software, well, they started to creak under the strain.
Think about it. In just the last couple of decades, the hardware we run our code on has completely changed. We went from single-core processors to chips that have multiple cores, and from single servers to these gigantic global cloud networks. Our machines can now do a ton of things all at once.
But here was the disconnect. The hardware was screaming ahead, but our programming languages were kinda stuck in the past. Trying to write code that could actually take advantage of all that new parallel power, it was becoming a total nightmare, just full of complexity and really nasty bugs. Now, this ability to handle lots of tasks at the same time, it has a name: concurrency. A perfect example is something like Google Drive. You can be uploading a massive video file, but you can still browse through your folders and organize your stuff at the exact same time. That's concurrency in action, and it's what makes modern apps feel so snappy. But this opens up a whole new can of worms. Imagine two people trying to book the very last ticket for a concert, and they both click buy at the exact same millisecond. The system has to be smart enough to make sure only one person gets that ticket, right? That's the core challenge of concurrency. If you're not careful, you can end up with total chaos. So Google was in a tough spot. They needed a better way to build huge systems that could leverage all their incredible infrastructure, but without all the headaches that came with it. Their solution? They decided to build a new language from scratch. They called it Go.
So back in 2007, a team of absolute legends at Google, we're talking some of the same people who invented foundational technologies like Unix and C. They decided to fix this problem once and for all. The result was Go. And by 2009, they made it open source, giving it away to the world. Their whole philosophy was to get the best of both worlds. They wanted something as simple and easy to read as a language like Python, where you can just write what you mean. But they also needed the raw horsepower and efficiency you'd get from a low-level language like C++. Go is born with some serious superpowers. For one, it compiles code incredibly fast. Your programs also run with amazing performance, and they sip on CPU and memory, which is super efficient. And maybe best of all, a whole Go application compiles down to just one single file. That makes deploying it unbelievably easy. Okay, so how does Go actually pull all this off? The secret, the real magic, is its obsession with one thing: simplicity. Let's take a super common task, just storing a list of things. A lot of languages give you a whole bunch of confusing options for this. Go, on the other hand, gives you one simple and really powerful tool. It's called a slice. Just think of it like a smart to-do list that can grow or shrink whenever you need it to. And just look at how clean that is. Seriously, in one single readable line, we've made a list of tasks. There's no fluff, no extra ceremonies. You just say what you want and you get it. And using that list is just as straightforward. Go gives you a really simple for loop that just lets you walk through each item one by one. This clear approach helps you avoid the kind of confusing, bug-prone code you might find elsewhere. And of course, to keep things tidy and not repeat yourself, you use functions. You can just wrap up a piece of logic, like, say, the code to print your to-do list, give it a name, and then you can call it from anywhere. It's all about writing clean, maintainable code. But don't let all this simplicity fool you into thinking it's not powerful. Because here's the twist. It's exactly this focus on simplicity that lets Go run some of the most massive, most demanding systems on the entire web. In fact, Go comes with an amazing toolbox built right in. Check this out. With just a couple more lines of code, we can take our simple to-do list app and turn it into a full-blown web server. Just like that, it's accessible to anyone on the internet. It's honestly incredible how fast you can build things. And this is where Go's design really shines. In the cloud, where your app might need to handle thousands or even millions of users all at once, Go's natural ability to handle all that concurrency is an absolute game changer. So this mix of being simple to use but also incredibly high performance, well, that's what's made Go just explode in popularity. It's basically become the default language for building the backbone of the cloud. I mean, just look at the tools that are built with Go.
We're not talking about small projects here. We're talking about Docker, the foundation of containers, and Kubernetes, the system that manages all those containers at a massive scale. These are literally the building blocks of the modern internet. So if you boil it all down, Go's success really stands on 3 pillars. Its simplicity means developers are more productive and the code is easier to manage. Its performance means your apps are lightning fast. And its built-in concurrency makes it the perfect fit for the massive, distributed world we live in today.
And this quote just nails it. The whole point of Go wasn't just to add more bells and whistles. It was about stepping back and making the incredibly complex job of writing modern software, well, just a whole lot easier.
Which leaves us with a fascinating final thought. As our digital world gets more and more complex, could it be that simplicity is actually the most powerful feature of all? As we keep building the future, will languages like Go, that put clarity and scale above everything else, be the ones that really last?